Hi. What I want to cover today is a continuation of data analysis that we started and was not able to finish. If you'll notice, I got rid of the video. I'm thinking that might be a little too distracting, seeing my ugly mug every day. So besides, it's blocking too much of the screen. So today we'll go without video and we'll see how it works. So the 2 points today are analyzing graphical relationships and straightening the curve. So there's 4 graphical relationships. We have a linear relationship, quadratic or power relationship, inverse, and square root. So these 4 relationships are what you normally see, and we try to use what we know about these relationships to identify an equation or some type of a general rule that'll fit to our data. So for each relationship, we're going to try to identify what the equation of the graph would be. We're going to identify the shape of the graph and the name of the curve and how to straighten that curve. And so let me take you through each of those relationships. The first one is the linear relationship. We know it's linear because the data points seem to line up. They make a line. So linear means line. The equation is written y equals mx plus b, and the y and the x letters in this equation represent the variables for the x and y axes. M is the slope and b is the y-intercept. This is probably the most important relationship you're going to need because every piece of data that we graph, we're going to eventually try to put it into a linear relationship, something that we understand better. You should understand the picture of the graph. The picture should show that the points line up. And the points aren't going to line up exactly perfect all the time, but you should see a general upward trend or downward trend where you can imagine that if a straight line was put through that data, the data would pretty much fit pretty closely to that line. And it's got to be straight again. If you see any curves in the data, it's definitely not linear. And so there's no reason to try to straighten this graph because it's already straight. And we'll talk with the other types of graphs how to straighten them. The second relationship is the power relationship, and this is when we raise some variable up to a power like x squared or x cubed. That would give us an upward trending or upward curving graph. So you can see here that a general equation might be y equals kx squared, where k is any constant, could be any number that's fixed, it doesn't change. And our x-axis is squared. So as x increases, that gets squared and it makes y that much bigger. And so you'll see this upward trending and curved line. So that's the picture of the graph, and we call this type of graph a parabola. In order to straighten it, what we do is we apply that relationship to the x-axis. So if we want to straighten a power relationship, if we want to make this parabola look straight, what we do is we graph y versus x squared. So after we identify what type of graph it is, we can straighten that graph by applying some type of rule to the x-axis only, and we'll end up with a straightened graph. And I'm going to show you some examples in a minute. The next relationship is the inverse relationship. The inverse relationship shows a downward trending curve. It's not straight again, but as our x values increase, notice what's happening to the y values. The y values are decreasing. So the equation for this would be y equals k over x, where k is some constant. It could be any number, doesn't change. X and y are our variables, and notice that as x increases, it makes y smaller because x is on the bottom of a fraction. And so there's the picture of the graph, and this type of graph is called a hyperbola. And if we want to straighten this graph, we just graph y versus inverse x. So again, we don't touch the y-axis, we only change or manipulate the x-axis in order to see this relationship. And I'll show you some examples in a minute. The next one is a square root relationship. And a square root relationship, it looks opposite of the inverse relationship. Instead of starting out big and ending up small, we start out small and end up big, but it's flipped upside down. So it's curved the opposite of a power relationship. The equation would be y equals k root x, where k is a constant, it doesn't change. X and y are your variables. And so if you plug in numbers for x, you'll notice that y approaches some number, but it never actually gets there. So y can be only a certain maximum number that it can't go over. There's a picture of the graph, and it's a parabola again, but it's flipped upside down. And so to straighten this, we would graph y versus square root x. Another way of looking at a square root relationship would be if we squared both sides. So if we squared both sides, we'd end up with y squared equals some constant k times x. So if your y-axis is ever squared, then it really is a square root relationship. And again, we don't touch the y-axis, we only manipulate the x-axis. And so you can see this upward curving trend right here, and it ends up approaching some number. So how do we straighten the curve, and what's it all about? To write the equation of the line, we have to replace the x variable in the y equals mx plus b with the new x variable on the x-axis. So what we're going to do in each of these situations, we're just going to manipulate the x variable. Let me get my pointer here so you can see what I'm talking about. So for this first example, we're looking at a power relationship, and you can see that we have an upward curving trend. I'm just trying to freehand this. I know it's kind of wavy, but it's definitely not straight. It's an upward curving trend. And so what we're going to do, since we know that it's a upward curving trend, and this is a power relationship, we don't know exactly how much it's curved. But to figure that out, what we do is we apply a rule, I guess you could say, to the x-axis. And so notice here we're graphing distance versus time. And this could be anything. It could be a track runner, it could be a guy on a bike, it could be a car, where it starts out at a relatively low speed and gradually increases speed, so the slope gets bigger. So anyways, to straighten this, we square, since we know that this is a power relationship, we square the x values. So in our data, we're going to actually calculate the square of time for each data point. And then what we graph is distance versus time squared. And you'll notice that this now approximates a very straight linear graph. And again, I'm trying to freehand this, so it might not look straight, but that's much straighter than what we had originally. For the next type of graph, it's an inverse relationship. Again, the original graph, we see this downward trend. So we start out at some value, and we gradually come down and start approaching some number. So that's not linear either. And we know it's an inverse relationship because as x increases, y decreases, but not at a linear rate. So to straighten the graph, we don't touch the y-axis. This time, we manipulate the x data, or x variables. So what we do is we apply 1 divided by x for each data point, and we graph distance versus inverse time. And again, that approximately straightens our data. So the purpose of this is to come up with a relationship. In order to see this relationship better and to validate and verify that it is an inverse relationship, if we try to straighten it with an inverse rule, then our data should come out very linear. What happens if we try to straighten and our data does not come out linear? Okay, for example, if I thought this was an inverse relationship and I apply this inverse rule to it and our data, it looks curved again, well, it wasn't an inverse relationship. So we have to go back and try to identify which relationship it may have been. And the last one would be the square root relationship. Notice for this, we start out, where's my pointer? There it is. We start out big, and the slope starts getting smaller and smaller until we approach some number. To straighten that, we just graph distance versus square root of time. And so this is the axis or the variable that gets manipulated. And again, our data should come out, if we graph this, it should come out linear. And when we look carefully at the equation of this line, the y equals mx plus b equation, if we were to calculate the slope and the y-intercept, that would give us a lot more information on what the equation of the original graph is. That's the purpose of this, is to figure out the equation of the original graph. So that takes us through graphical relationships and straightening the curve. What I'll do is I'll make another separate video on how to do this in your calculator, and later how to do this in Microsoft Excel.